Well, hello and welcome to our Maths and Stats Success workshop. Today we are going to be looking at linear functions. My name is Samuel Brown and you can see my email address here if you need to get hold of me. But I hope this should be put on Blackboard so you should be able to get access to it. Okay, so what are linear functions? So linear function is basically a function of the form f of x equals ax plus b, where a and b are real numbers. Okay, what does that actually mean? I mean, that's just crazy maths talk, but it is very simple. So f of x means a function of x. So it's going to be anything that is a function of something else. For example, quantity supplied, or Q, is a function of price, or P, as you can see here. So we can get an equation like Q equals AP plus B. Basically, quantity is a function of price. Okay, here A represents the gradient or the slope of the line. So it's how steep it is, whether it's a very steep line or shallow. And so it means that for every extra pound, every extra dollar, every extra increase in price, there'll be an A extra of quantity. So if A is 2, then for every extra pound, the quantity supplied will increase by 2. And B represents the y-axis, or the vertical intercept. This basically is where it crosses the vertical line. And so this is the amount of quantity supplied when the price is 0. So if B is 7, for example, then if the price is 0, there will be at least 7 supplied. Okay, so let's look at an actual example then. So here we've got f of x equals 2x plus 3. So for each increase in x, f of x will increase by 2. We can see that by the 2 attached to the x there. So for each new x, f of x will increase by 2. And when x is 0, f of x will be 3. So again, we can just sort of get rid of that part, and we're left with f of x is equal to 3. Nice and simple. But what about plotting it? Well, we can plot this by working out what f of x will be at various values of x. So when x is 1, we simply just replace x with 1. So it's 2 times 1 is the 2x here. 2 times 1 plus 3 equals 2 plus 3, which is 5. So when x is 1, f of x is 5. Similarly, when x is 2, we get 2 times 2 plus 3, which is 4 plus 3, which is 7. So when x is 2, f of x is 7. And when x is 3, f of x is 9. So you can see a pattern here, 5, 7, 9. It's increasing by 2 every time. And makes sense because, as the name suggests, a linear function will be a straight line. So basically what we're going to get is we're just going to get a line that increases by 2 each time for each extra unit of x, and it will cross the y-axis at 3. And we can see that here. So as you can see, crosses the y-axis at 3, and for each extra unit, there is an increase of 2. So for 1 extra unit of x, there are 2 extra units of f of x. And we can see it crosses the y-axis at 3. Okay, so what happens if we change some of these numbers? So what happens, for example, if we increase 2x to 3x? Well, what's going to happen there is the slope will increase. It will become steeper. Yep, so now if we move one across, we get 1 extra unit of x, we get 3 units of f of x. Now you'll notice that it does still cross the y-axis at the same point. The y-axis intercept is still 3. Similarly, if we have half x, 0.5x, we can see that the slope is a lot shallower. So for every increase of 1x, we get half an increase in f of x. Okay, well, what about minus? What does that do to the situation? Let's have a look. If we get minus x, then again it's still going to cross at the same intercept, but this time it's going to be sloping downwards. So this is essentially the same as minus 1x, and so for each unit increase in x, there will be 1 unit decrease in f of x. Okay, so we know what happens when we change the gradient when we change the a part of the equation? What happens when we change the b, the intercept? Well, let's see what happens when we increase the intercept. So let's take it from 3 to 5. We can see that all that happens is a shift upwards from the intercept being 3 originally, it's now 5. But the gradient, the slope of the curve, doesn't change at all. Similarly, we can go down, we can take it down to +1, and we can see that the intercept is now at 1. So again, it shifts, there is no change in the slope, it just shifts down to 1. Okay, again, well, what about minus? It's simply another shift. It's just going to be below 0 now. So you get the y-axis intercept is at -1. And again, the slope remains the same. Okay, so it's simple enough to graph this. All you have to do is, again, plug in some numbers for what x could be, and then you can plot on the graph, and then if it changes, you can work out, well, will it get steeper or shallower if the a part changes, and where will the intercept be if the b part changes. You can also follow these in the notes that accompany this talk. The numbers that are used in that are slightly different. I just wanted to give you a bit of variation in the numbers, but it's essentially the same thing. So what about non-standard forms of linear functions? Well, linear function may be written in a different form, so not f of x equals x plus b. So for now, what we're just going to do, we're going to assume that f of x is equal to y, just for the sake of ease. And what happens if we have a function like 3x plus 6y equals 12? Now, obviously, that is not in the same form as f of x equals ax plus b. We can't really tell what here is a, b, or f of x. And so what we can do is we can just rearrange it to make y our subject. So basically, this means we want to get y on the left-hand side all by itself. How do we do this? Simple rearrangement. Okay, so we start with 3x plus 6y equals 12. Then we minus 3x from both sides. We'll get rid of it from this side. So 3x minus 3x is 0. And we're left with 6y equals 12 minus 3x. So that's what we've got here, 6y equals 12 minus 3x. I'm just going to swap those round, as you will see in a second, so we can get in the final form. And then if we divide by 6, we can have y by itself, so we're left with minus 3x over 6 plus 12 over 6, or minus x over 2 plus 2. Now this, we can see, is the same form as f of x equals minus 0.5x plus 2. So all we had to do there was rearrange it to make y on the left-hand side. As we said earlier, f of x is equal to y, and so y equals f of x. So it's just about rearranging it to make it clear what is what. Now you can easily plot this the way we previously plotted. Okay, another example. What if we have 4y minus 8x plus 2 equals 0? Okay, so this one, again, we just want to get y on the left-hand side by itself. So we'll take the 8x minus 2 over to the other side. We divide by 4. We're left with 8 over 4x minus 2 over 4. Or that's the same as 2x minus 0.5. So again, we've moved it into a situation that we're familiar with. But what we could actually do is we could also make this a function of y instead of a function of x. So here, we make x the subject. Okay, so we get x on the left-hand side, and have 4y plus 2 on the right. Then we divide by 8 to get x by itself. So we're left with 4 over 8y plus 2 over 8. And that can give us a function of y, rather than a function of x. And we're left with a function of y equals 0.5y plus 0.25. Now again, you'll see function of y, and we've got y here. As we saw earlier, it's a function of x, we've got x here. So when it's a function of a different variable, that's the variable that you find in there. Okay, now if we plotted this on the same graph with the y and the x-axis in the same way, then we'll find that assuming that the x and y axes are the same, when plotting this, it will be the same as the f of x equals 2x minus 0.5. It's the same graph, it's just as a function of y rather than a function of x. However, what we usually find is that whatever we're looking at the function of, that will be on the y-axis. So function of x would normally be the y-axis, and the x naturally would be the x-axis. Or, for example, the example we had earlier was quantity in terms of price. So quantity would be the f of p, which would be on the y-axis, and then price would be on the x-axis. So it's just a matter of determining what goes on the y-axis, what goes on the x, and then you can plot them in the same form that we find here. Now going back briefly to this one, as I said, that if we use the same axes, so we plot y up there, it's simply a matter of, again, replacing y with a number, and then we can plot exactly where that will be. You just have to sort of turn the graph around in your mind so you can plot accurately what is y and what is x. Okay, thank you for listening to me, and I hope you find this useful.